WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.
Hello viewers, welcome to Eko Learners Support for WAEC and NECO candidates. I am your physics tutor for today, and today I'll be taking you through Newton's laws of motion. Follow me as we go.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Newton's laws of motion. Here in this topic, we'll be considering linear momentum, collisions, and then the types of collisions, and afterwards we'll take some simple calculations under it. But at the end of this class, you should be able to state the law of conservation of linear momentum. You should be able to describe and explain what collision is. You should also be able to clearly distinguish between between elastic and inelastic collision. Now, what is momentum? Momentum is the product of the mass and velocity of an object. So which means that for a moving object, it has momentum. But for an object at rest, there is no momentum. There's a principle that holds for the conservation of linear momentum. It is that all momenta before collision will be the same as after collision. But then, this happens in an isolated system, which means a system where there is no influence of external force. So this principle of conservation of linear momentum states that in an isolated system, colliding bodies in total linear momentum in a fixed direction remains unchanged or constant. What it means is that momentum before collision is the same as momentum after collision. So which means that if you have two bodies colliding, the momentum they have before colliding will also be the same momentum after colliding, irrespective of whatever happens, once there is no external influence coming into this collision. Now, like I said, this means that total momentum is constant, and then it is true for all the type of collision that we have. We have two types of collision. We have the elastic and the inelastic collision. For the elastic collision, it happens between two bodies. Once they hit themselves, once they collide, they move with different velocity. From the word elastic, to be able to move apart. So look at it. If you have this object moving and in a way there's a collision between the two of them, after the collision, both of them move their separate way. We say this is an elastic collision. Example, the collision of gas molecules. It is elastic because once they hit themselves, they move their separate way. They don't stick to each other. That's what we call is an example of elastic collision. So what happens here is this. This object initially, it has an initial velocity. Let's say this is object 1. this is object 2, this is object 1, this is object 2. So this one also has its own initial velocity. It has a mass. This also has a mass. So once there's a collision, what happened here is that there's collision here. So here, it has a new velocity. This also has a new velocity. This has retained its mass. This also retained its mass. So what happened? Momentum is the product of mass and velocity of an object. So in this case, you're going to have m1 u1 plus m2 u2, leading to momentum here, m1 v1 plus m2 u v2. So what happened here is that all the momenta before collision is equal to the momenta after collision. So you can see it here. That is what you have here. Now, for inelastic collision, what happens in inelastic collision is that once the object hits, once they collide, they stick together. So this is an inelastic collision. So this is object 1, object 2, object 1, object 2. Initial velocity here is u1, initial velocity here is u2. This is m1, this is m2. So the momentum here is m1 u1. The momentum here is m2 u2. When you add the two, will still be the same thing as the momentum here. So the momentum here is that since they are sticking together, they are going to share common velocity. Final velocity will be the same. So m1 plus m1v plus m2v. So you look at it, the velocity is common. You are going to have m1 plus m2. They have v in common. So this is why it is always written this way. Because once the objects collide, they stick together, they move with the same velocity. Then in that case, we say we have an inelastic collision. Let me add this information for elastic collision. In elastic collision, kinetic energy is also conserved. Here, both momentum and kinetic energy, they are both conserved. But for this inelastic collision, it is only momentum that is conserved. Kinetic energy is not conserved. It can be converted because at the moment there is collision, that collision would have bring about loss in kinetic energy, and it's possible that the kinetic energy has been converted to sound energy or heat energy. So it will reduce what the output or resultant kinetic energy. Now, I want you to take note of something before we go into the calculation that follows this topic. There is the direction of collision has a place to play in our calculation. When two bodies collide, if they are moving in the same direction, it has effect. I will show you. If this object is moving this way and this other one is moving this way, if they collide and stick together, it means m1 u1 plus m2 u2 will produce m1 plus m2 v. That's the case recorded here. Two bodies moving in the same direction before collision, but after collision they are sticking together. That's why you have common velocity. If they are not sticking together, it means m1 u1 plus m2 u2 will be equal to m1 v1 plus m2 v2. That is if they are not sticking together. Now, in this case, two bodies traveling in opposite direction. Please take note, same direction, opposite direction. If they are traveling in opposite direction, which means the first one, this is 1 and 2, 1 and 2. The first one and the second one. This is going this way and the other one is going the opposite way. Remember that speed is a vector quantity, is a function of magnitude and direction. Good. So in that case, this is going to be m1 u1 minus m2 u2. Why? It's supposed to be plus, but this value here will be minus because it's negating the direction of 1. So when you now say minus times plus, you now have m1u1 minus m2u2, which is equal to m1u1 plus m1v1 plus m2v2. This is if they don't stick together. But if they stick together, you're going to have m1u1 minus m2u2 equals to m1 plus m2. They will have the same velocity. That is how it will be. But if you're having it as a stationary body, if there's a collision with stationary body, a stationary body is an object that is not moving. So once the object is not moving, initial velocity is 0. So which means that if you have this collision now, if this is having u1, u2, v1, v2, if this is stationary, it means u2 is equal to 0. So what it means then is that m2u2 will be equal to 0. So which means that the initial momentum for the second object that is at rest will be 0. So implicit to that, you are going to have m1 u1 plus m2, because u2 is 0, everything here becomes 0. It will be equal to m1 v1 plus m2 v2. This is if they move in different direction. That is, if they move separately, that is elastic collision. But if it is an inelastic collision, it means m1 u1 plus 0 will be equal to m1 plus m2 all into bracket of v. V being the common velocity because they are moving together. So with this, let's look at few examples before exercise. Example 1, 2 moving toys of masses 50 kg and 30 kg traveling in the same plane with speeds of this and this. In the same direction, watch the same direction. If they collide and stick together, calculate their common velocity. They stick together. So watch the statement, the same direction, then stick together. If they are sticking together, it means the final velocity will be the same thing for the two of them. So in this case now, we want to make V the formula first. So from here, you say V equals to MA UA plus MB UB over MA plus MB. So V will be equal to the value of the first mass, that's 50, times the initial velocity is given here as 5, plus the second mass, which is 30, times the second velocity, which is 3, all over 50 plus 30. So from here, you are going to have 250 plus 90, all over 150. When you do that, 250 plus 90 will give you 340, all over 150. When you divide 340 by 150, you are going to have 4.05. 50 plus 30 should give, not 50, okay, 50 plus 30 should give 80, sorry, not 180. So 340 divided by 80 will give 4.05. Example number 2. 2 balls of masses, all right, 2 balls of masses 0.5 kilogram and 0.3 kilogram move towards each other. Now from that statement, move towards each other. For objects to move towards each other means they are in opposite direction. So if they are in opposite direction, one will pick the primary direction and the other will be the negating direction. So the first one is what we refer as the primary direction here. So the velocity here is positive. And the other one, the second one, is what we refer as the opposite direction. That's why it's having -4. So mass times velocity, 3 times 0.5, you have this. 0.3 times 4, you have this. Plus times minus gave us minus. So when you subtract, you have this. Now in this case, 0.5 times -1. How did we get this -1? Let's go back. After collision, the first ball has a speed 1 meter in the opposite direction. So that word opposite direction, which means the new direction it's facing negates the original direction it's coming from. So that is why this one is minus. So when you multiply, you have this, then 0.3 is here. So when you make this is the formula, this come here. You're going to have 1.5 minus 1.2. That's 1.5 minus 1.2. You're having 1.3. This should be 1.3. Then this coming here, okay, yes, it's still correct. Yes, it's correct. Look at this. If 1.5 plus 0.5 minus 1.2 equals to 0.3 V. When you add these two, you are going to have 2.0 minus 1.2 equals to 0.3 V, which correlates with this line. When you subtract, you have 0.8. 0.8 divided by 0.3 gives 2.7 meters per second. Let's look at the next example. A gun of mass 100 kilogram fires a bullet of mass 20 gram at a speed of 400 meters per second. What's the recoil velocity of the gun? The momentum of the gun is equal to the momentum of the bullet. Don't forget the principle of conservation of linear momentum. So in this case, this is for the gun and this is for the bullet. So the mass of the gun, the mass is given as 100 times v velocity of the gun. So which is equal to the mass of the bullet, which is 20 gram. So let me write it here. The mass of the gun, 100 times v equals to this divided by 1,000. That will be converting to kilogram. That will be 20 over 1,000. This is going to give 0.02 kilogram. So this is going to be 0.02 times V, that is 400. So in that case, these two zeros goes for these two zeros. So V will be equal to 0.02 times 4. So the velocity gives 0.08 meters per second. So I think the error is from here. It's supposed to be divided by 100. So that is it. So this is going to give 0.08 meters per second. Thank you. That is what you have for this. Now, I have some questions for you to play with. Look at these 3 questions. I want you to go through it, and I'll come back the next 2 minutes to compare our answers. All right. Now, let's look at it together. State the principle of conservation of linear momentum. The force that acts on a body. Now, let's look at the first question. The principle of conservation of linear momentum is telling us that in an isolated system where there's no effect of influence of external force, the total momentum before collision is the same as total momentum after collision. Now, look at the second question. a force acts on a body for 0.5 seconds, this is time, changing the momentum from this to this. Calculate the magnitude of the force. From here, remember that from Newton's second law of motion, force is changing momentum over time. So the force, what's changing the momentum? Changing from 16 to 21. That is 21 minus 16 over how long? 0.5. So from here, you're going to have 21 minus 16, that is 5 over 0.5. When you divide this, you're going to have 10 Newton. And the correct option for 10 Newton is option D. The last question. A machine gun with mass 2.5 kilogram fires a 50-gram bullet at a speed of 10 meters per second. The recoil speed of the machine gun is this, is the question we have to calculate. So from here, you know that momentum of the gun will be equal to momentum of the bullet. So from here, we are looking for the speed of the gun. V will be equal to mv for the mass, for the bullet over mass of the gun. So from here, you're going to have V equals to mass of the bullet. The mass of the bullet is given as 50 gram divided by 1000. You're going to have 0.05 kilogram, converting to kilogram. So that 0.05 times velocity of the bullet is given as 100 over mass of the gun, that's 2.5. So when you multiply this, you're going to have 5 over 2.5. So when you have 5 over 2.5, 5 divided by 2.5 will give you 2.0. That will be meter per second. So the correct option here is option D, which is 2.0 meters per second.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
I want to believe that you have learned something from today's class. So if you have question, observation, suggestion, or whatsoever, feel free to forward it to us through our social media handle that is going to be displayed on the screen. So we meet again in the next class. Have a nice day.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.